Yes, I'm done, ma'am. So done, sir.
Okay. Thank you. Thanks.
Thank you.
So, hi. Today we'll be discussing implicit functions. So, till now, all the functions that we have discussed were of this form, right? We had y is equal to terms of x. So basically, what was happening was that the terms of x and y were separated. On one side you had complete all the terms of x, and on one term, on one hand side, you just had y is equal to term of x. So basically at any point x, you could have calculated your value of y simply by inputting your value of x. But so like for example, you have got this function y is equal to x plus 6, y is equal to sine of x, y is equal to anything, cos of x into tan of x, something like this, or anything, literally anything, log of cos x, anything, right? Anything. So what was happening is that y is equal to and the terms of x on the right hand side. But in many cases, what happens is that the terms cannot be separated, right? The terms are not separable in many cases. Like for example, we discussed this case y plus sine of y is equal to, let us take what we'll take, x square plus 2x plus 3. We have got something like this. So over here, even your left hand side is a function of y. Or for example, you have something like y plus xy plus y square plus 2x is equal to 0, something like this. So over here, what is happening is you won't be able to calculate the exact value, or you won't be able to separate out the terms. So how will you find the derivative of such a thing, right? So even though we have done it before, we'll be just revising it again about how we can go about taking the derivatives. So what you can do is, in an easy case, assume y to be a function of x. Okay. Assume that your y itself is a function of x and then apply chain. Okay. Really easy. So like you don't need to actually do anything. So let us try this one. So this one is really easy to start with. So you have got y plus xy plus y square plus 2x is equal to 0. Fine. So what you do is you treat y as a function of x. You treat y as a function of x. So you can assume y to be like for your mind map, you can just assume your y to be some function f of x. So your equation becomes f of x plus x into f of x plus f of x whole square plus 2x is equal to 0. What can I do next? Gayatri or Ashrita, what can I do next? I've got this equation. What is the next step that I can take? Can you tell? I can differentiate this whole equation with respect to x, right?
Yes, sir.
Right.
Yes,
So
sir.
can you tell me what will be the right hand side? If I differentiate 0 with respect to x, what will it be?
0, sir.
Yeah, 0, right, is equal to. So let us start. What is the derivative of f of x?
F dash x.
Great. Plus, what about this one? X into f of x. So basically, you have got two functions in multiplication. The first function is x, second function is f of x. How do you
Perfect.
derivate? What do you do? Like, how do you take the derivative of multiplication? Tell me. How do you do that?
First term derivative, second term constant plus.
Okay, great. So you do the other way around in the second term, right? So you differentiate x and then keep as it is. So x, what is the derivative of x? 1,
1, sir.
right? Yeah, so
Yes,
1 into f of x. So f of x plus, now you keep x as it is and keep it as f dash x, right? Plus, now you have got f of x whole square. F of x whole square. Can you tell me which function has been inserted inside which function? F of x whole square. You have got f of x whole square. How will you differentiate this thing? It is like very basic chain rule. Can you tell me?
x square is inserted in f of x.
No.
F of x is inserted
Is
in x.
inserted.
Yes,
Yeah,
sir.
like this, right? This
Yes,
is what
sir.
you mean? Yeah, it is correct. So you approach from the outermost side. The first function that you count is x square. The derivative of x square is 2x,
2x.
right?
Yes, sir.
So what will be the first term that I write over here?
2f of x.
2f of x.
Great. I completed my first level. I move inside. I found f of x. The derivative of f of x is directly f dash x,
F
right?
dash x.
Yes, sir.
Plus, what is the derivative of 2x?
2, sir.
2, sir. 2, sir.
Equal to 0, right?
Yes, sir.
Right. So, like I can just uh, revert back and write f dash x as dy by dx. So my equation becomes 0 plus dy by dx plus y plus x into dy by dx plus 2y into dy by dx, right? Plus it will be 2, right? Right? So now I can separate out my dy by dx and terms of x and y, right? Is it possible? Now I can separate out my dy by dx, right? So we can do it. So it is y plus 2 plus dy by dx into what is the common? So 1 plus x plus
X
2y,
plus 2y. Yes, sir.
right? So my dy by dx becomes minus of y plus 2 divided by 1 plus x plus 2y, right? This is it. So I have calculated my derivative with respect to x of y. But you can see on the right hand side, I am getting both terms of x and y. So yeah, that is possible because earlier also you can see that my x and y were inseparable. I was not able to separate them. So obviously I should have got them in the answer also, right? Do you agree, everyone?
Yes, sir.
Okay, great. Okay, great. Then let us just try this one. Okay, so like I just want you to think of y as a function of x, and like you actually don't need to do anything. After you have thought this, you don't actually need to substitute y as f of x and then do the whole thing as f of x. Just it was just for your mind map. So now just clarify it and let us try it in this way only. So differentiate with respect to x on both sides, right? Can you tell me what will be the right hand side if I differentiate it with respect to x? My right hand side with respect to x.
Minus sin x.
Yeah. So on the left hand side, we have got y plus sine of y. Okay. Y plus sine of y. The first term is really simple. It is y. So the derivative is dy by dx, right? With respect to x. The derivative is dy
Yes,
by
sir.
dx. After that, you have got sine y. Sine of y. Can you tell me which function has been inserted inside which function? Sine of y. So like you can see easily sine x, inside that y has been inserted, right?
Yes,
Yes,
sir.
sir.
So you approach from the outermost side. The first function that you get is sine x. You differentiate it, you get cos x. So what will be the first term that I write over here?
Cos y.
Sir. Cos y, sir.
Okay, I complete my first level, I move inside, I find y. I differentiate it. What is the derivative of y?
dy by dx.
Y by dx.
right? This is it.
Yes, sir.
Yes, sir.
Yeah, yeah. So you have it.
Yes, sir.
So minus of sine x is equal to dy by dx into 1 plus cos y, right? So dy by dx is equal to minus sine x divided by 1 plus cos y. This is your answer,
Yes.
everyone?
Yes, sir.
Okay. Great. Then let us try a few tougher ones. Okay. So you have got this. xy plus y square is equal to tan x plus y. So let us see how we can do it. So again, like the process remains same, right? You differentiate both sides with respect to x. First of all, you will check if there is a way to separate out y and x. But there is no possibility because you have got y square and then tan x. So that's not possible. So differentiate with respect to x directly. So let's do the right hand side. It looks easier. So can you tell me what will be the derivative of right hand side if we differentiate it with respect to x? Anyone?
Secant square x plus dy
Great,
by dx.
Y by dx,
great.
sir.
Yeah, great. On the left hand side, you have got xy plus y square. So let us look at xy first. So xy is basically, so you again think y as a function of x. So x into some function f of x. So how do you differentiate two functions that are in multiplication? So again, you do the same thing, right? You keep the first function intact, the second differentiate, and then the other way around. So you differentiate the first function first. So the derivative of x is 1. So 1
1
into y
1 into
plus
plus
x into, tell me,
t
E by
tell me,
dy by
what will be
dx.
this?
dy
dy by
by
dx, sir.
dy by dx. This, are you sure? Just check it again. You don't need to differentiate both the functions at the same time. Check it again and tell me.
xy, sir.
I did x into dy by dx, right? See,
Yes.
in the first case, you differentiated x and you kept y as it is. After that, you keep x as it is and differentiate y. So this is what you
Yes,
will get.
sir.
Yeah. Okay. So over here you got y plus x into dy by dx, right? Do you
Yes.
agree?
Sir. Yes,
Okay.
sir.
Plus, after that you have got y square. Can you tell me which function is inserted inside which function? Y square.
Y is inserted in tan.
X square, sir.
X
Sorry,
square.
like it is y square, right?
Yes, sir.
Yeah. So which function is inside which function? Tell me. Who will tell me?
Y is inside x square.
Ah, great. Inside x square, y square. Great. I start from outermost side. I get x square. I differentiate x square. I get 2x. So what will be the first term that I write over here?
2y.
Y, sir.
Y. And what about my next term?
Y dy by
Y
dx.
by dx.
Great. Great. Chain rule, right? Easy chain rule. So now you can separate out your dy by dx, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
right?
Yes, sir.
So your value of dy by dx is secant squared x minus y whole divided by x plus 2y minus 1. Okay, so I want you to tell me if I have a particular value of x given to me. So for example, it is given to me that value of x is some constant c. How will I find the dy by dx at that particular point? What should I be doing? Can you tell me, anyone? If I have been given a particular value of x, let us assume a particular value of x as c, what will I do in that case? Anyone?
Substitute x value.
Okay. So if you can substitute your x value directly over here, great. Okay, so I'm back. So great. So as I had asked you that if you are given a constant value of x equal to c, so you rightly said that you can substitute it. You can substitute your value of x given to you. But what will you do of y? What will you do of the terms you have in y? How would you handle that? Am I audible? Everyone?
Sir.
Okay, I'm audible. Great. So, like, you will have some terms of y also. You're on your right hand side. What would you do about that? Anyone? So, like, for example, you will be given x as some constant c. So you can use your value of x directly. So in order to find y, use the equation that's been given to you. So you have got this equation over here. In this, you can substitute your value directly. Okay, just substitute your value directly and you'll get your answer. So let us try one case. Okay, so let us try the value. Uh, okay, so let us try for x is equal to 0. And it's been given to you that y is greater than 0. Okay, so x is equal to 0 and y is greater than 0. So when you substitute dy by dx, you'll get secant squared 0 minus y divided by x plus 2y minus 1. So 0 plus 2y minus 1, right? So can you tell me what is secant squared of 0? What is it? Anyone?
Undefined, sir.
Are you sure? Secant squared of 0 is undefined. No,
One,
it's
sir.
1 by cos. It's 1 by cos square, right? Cos square of 0 is 1. So 1 by 1. So it is 1, right? 1 minus y divided by 2y minus 1, right? Is this correct?
Yes, sir.
Everyone? Okay. Now, what would you do about y? How will you find y? So use your original equation. Sorry, can you repeat? Omkar, Shriram. Okay, so just use your original equation. So you have got xy plus y square is equal to tan x plus y. Okay, this was given to you. So in your original equation, just substitute x is equal to 0. So you'll get 0 plus y square is equal to 0 plus y. So you'll get y square is equal to y. So y square is equal to y, and it is told to you. What is told to you that y is greater than 0. So you'll get two, like you'll get y square minus y is equal to 0. So you'll get two roots from here. One root is 0, another root is 1, right? Everyone. So which value of y should I consider? It's been given to me that y is greater than 0. So I'll consider this value. So my value of y becomes 1.
One, sir.
So after that, so I can just substitute it directly. So it is 1 minus 1 divided by 2 minus 1. So my answer is 0. Right? Got it, everyone? Everyone understood what to do at a particular value of x? Anyone who has any doubt? Shravani, Ashrita, Gayatri, did you get it?
No, sir. Yes.
Okay.
Sir,
Uh,
explain.
okay. No issue. So for example, you have got this equation xy plus y square is equal to tan x plus y. Okay. This is an implicit equation. Okay. Implicit function. Implicit means that x and y are inseparable. You are not able to separate them and write it in different sides. So what we do, we first of all differentiate the whole equation with respect to x. We have found out our dy by dx successfully. Okay. We have found out dy by dx successfully. But for example, okay, so on your dy by dx in the right hand side, you see that you have got terms that require both x and y. So you know what is the value of x. It has been given to you that the value of x is some constant c. So over here we took that our value of x is equal to 0. Okay. So in the right hand side, I am asking you to find the value of dy by dx when x is equal to 0. So obviously on the right hand side, you can substitute your values of x directly because you know what is your value of x. But how will you do the terms of y? Because you don't know the value of y. So you will go back to your original equation. You have got this original equation. In this equation, you will substitute your x is equal to 0. Okay. You substitute this, you calculate the value of y, and then you use it in your dy by dx. Fine. Is it clear now? Everyone?
Yes, sir.
Okay. So this is how you do it, and this is how we find the value at a particular point. Great. So just one last question before moving. Okay. K is any constant, any real constant. Fine. K is any real constant. So you have got sine square y plus cos of x into y is equal to constant k. So obviously, if I differentiate it with respect to x on both sides, can you tell me what will be my RHS? Differentiation of a constant with respect to x. What is it? Anyone?
0, sir.
Yeah, it is a constant, so it will be 0,
0.
right? Now I need to differentiate these two things with respect to x. So let us try the first term. So you have got dy dx of sine square y. So obviously we'll be going for chain rule. So in order to approach chain rule, can you tell me which function has been inserted inside which function? You have got sine square y. Sine square y.
Sin y is inserted in the y square.
Okay, actually your derivative is with respect to x, not with respect to y. Can you think again?
Okay.
Sin
The
x
function has
x squared, sir. Sin y inserted in
sine y is inserted inside.
Inserted
Great.
in the square.
this square.
Right? Is this correct?
Yes, sir.
Right?
Yes,
But
sir.
if you look closely, my sine y in itself is not a complete function of x. Do you all agree? Sine y
Yes.
is not a complete function of x. So I would need to bifurcate it further. Can you tell me what is? Okay, so like let us approach with the first step only then. Okay. So you have got the first function as x square. So what is the derivative of x square? How
2x,
do you
sir.
differentiate x? 2x, great. So what will be the first term that I get over here? What will be the
2x,
first term that I write? How
2x,
much?
sir.
X, sir.
2x.
2x. Are you sure? 2x.
2 sin y, sir.
2 into sine y, right? See, how to approach on chain rule. The terms that you have inside will come in place of x as it is. That won't change. Fine. Chain rule.
Yes.
Remember everyone? So
Yes,
if
sir.
inside x square sine y has been inserted, so if I get the derivative as 2x, so inside x this sine y will come as it is. That won't change. Okay. You got it?
Yes, sir.
Yes,
Great.
sir.
So you completed this level, you moved inside. Okay. Should I repeat?
Yes, sir.
Okay. See, I have got this function sine y that is inserted inside x square. I approach from the outermost side in chain rule. The first function that I get is 2x, is x square. I differentiate it, I get 2x. So in writing my first term, what I do is that all the part that I have inside x square will remain as it is, and then will come in place of x. Fine. So my first term that I'll write will be 2 into sine of y. Okay. 2 into
Yes.
sine y will be my first term, because in place of x, I'll keep everything that was inside x square. Okay. So I completed this level, I moved inside. I got sine y. Can you tell me which function is inserted inside which function? You have got sine y. How will you create a web chart of this? Anyone?
Sir, inside X, sin Y is inserted, sir.
Inside x, sine y is inserted. Like x in itself is, no. Just think again.
Yes, sir.
Use sine. Use sine.
Sir, inside sin X is inserted.
Yes, correct. Inside sin x, y has been inserted. Correct.
Y is
Correct.
yes, sir.
Everyone? Okay. So you approach from outermost side. The first function that you get is sin x. You differentiate it. You get cos x.
Cos
Can you tell
x.
me what will be the next term that I write over here?
Cos Y.
Cos y, sir.
Great. It will be cos y. Great. I complete this level. I met y. What is the derivative of y?
dy by dx.
Great work. So you got dy by dx. Correct. Now let us look at cos of xy. So you have got dy dx of cos of xy. So like this one also you'll approach in the same way. So you have got cos of xy, cos of x into y. Can you tell me which function is inside which function?
Sir, inside cos X.
Y
Great.
is inserted, sir.
xy is inserted. Great, great work. So you approach from outermost side. The first function that you get is cos x. The derivative of cos
Minus
x, what
sin
is it?
x.
Minus sin.
Sin
Sin x.
Great, great, sin x. So what will be the first term that I write over here?
Minus sin
Minus
XY.
sin x.
minus sin
Sin
x.
of xy. Yeah, great. I completed this. I moved inside. I got x into y. How will I differentiate x into y? How will I do this?
Derivative of x, y will be
Yeah.
constant.
Great. So basically, it is product of two functions, right?
Yes,
Product
sir.
of two functions.
Yes, sir.
So again, you keep the first function intact, differentiate your second function, plus then the other way around.
Y, sir.
Okay.
Yes,
Yeah.
sir.
1 into y. So 1 into y is y. Great. So into, so I just need to put this thing over here. So you have got x into dy by dx plus y. Fine.
Yes, sir.
Yes, sir.
So I just copy these things over here. So you have got this plus and then a minus. So I can just replace this plus and keep it
Minus.
as minus. Yeah. So now in this equation, can you separate out your dy by dx? Will you be able to write your dy by dx alone? Is it possible? We can do it, right?
Yes, sir.
Sir.
Yeah. Yeah. So you can find out your dy by dx. Okay. Fine. Let us just a minute. Okay. So we have got this question. So you have got 4x into e raised to xy. I hope your question is visible. Is the question visible, everyone?
Yes, sir.
Okay. So you have got 4x e raised to xy plus y plus 5 sine square x. And it is asking you what is the value of dy by dx when your value of x is equal to 0. Okay. dy by dx when x is equal to 0. So obviously we'll be doing the same thing. So I will differentiate both sides with respect to x. So let us do the right hand side first. It looks little bit easier. So when I differentiate it, it will be dy by dx plus. How will you differentiate 5 sine square x? 5 sine square x. I'm asking you to differentiate this thing with respect to x. How would you do that? This is basic chain rule. The derivative of this with respect to x. How will you do it? Or you can keep 5 as a constant outside because it is a constant. So it will come out like this. How will you differentiate sine square x? Anyone? Sine square x. Anyone? Chain rule. Which function is inside which function?
X square is inside in sin x.
X square is inside sin
It
x.
is inserted inside x square, sir.
Okay, great. See, if it was the other way around, if x square was inserted inside sin x, then it will be sine of x square, right? Not sine square x. It is sine square x, not sine of x square. Okay, correct. So x inside x square, sine x has been inserted. So that is why you'll get sine square x. Great. So you approach from outermost side, you get x square, you differentiate it, you get 2x,
2x, sir.
right? So what will be the first term that you write over here?
2 sin x.
Great. 2 sin
10
x.
sin x.
2 sin x, right? Yeah, 5 into 2. Yeah. So I have just
Yes.
kept 5 outside. What about, so after that you come to sin x. What is the derivative of sin x?
Cos x.
Mine
Cos
cos
x.
x.
Can cos x be directly written over here?
Yes, sir.
Great. So over here, your overall right hand side becomes dy by dx plus 10 sin x into cos x. Okay.
Yes, sir.
Okay, great. Now let us look at this side. This side looks a little bit tougher. So you have got d by dx of 4x into e raised to xy. Fine, you have got this. So your 4 can be taken outside. It is a constant. So you have got x into e raised to xy. X into e raised to xy. So it is basically a product of two functions. Do you agree? It is product of two functions.
Yes, sir.
Okay. So let us see how we can take product of two functions. So obviously, you first of all, you in the first case you differentiate your first function. So 1 into e raised to xy plus. Now you keep your first as it is and differentiate your second function. Right, everyone?
Yes, sir.
Great. So in this side, you would need the derivative of e raised to xy. Let us see how we can calculate e raised to xy derivative. We've got e raised to xy. Can you tell me which function has been inserted inside which function? E raised to xy you have.
XY is inserted in e raised to x.
Great. Chain rule, right? Basic chain rule.
Yes, sir.
So great. So you approach from the outermost side, you meet e raised to x, you differentiate it.
E
So
raised to
what will be the first term? What will be the
E-
first term that you write over here?
xy.
To xy.
Great. Multiplied by. So you completed this level, you moved inside, you met xy. How will you differentiate xy? We have done it so many times today. So it is product of two
I-
functions, right?
Yes,
Yes.
So it
sir.
is y plus x into dy by dx.
Yes, sir.
Sir.
Okay. So you have got this d by dx of e raised to xy. So just substitute it back. So you've got 4 into dy by dx, or you can just directly write it. So your this term is equal to 4 into e raised to xy plus x into, so just substitute this thing back. So e raised to xy into y plus x into dy by dx. Right? I'm just substituting it back. Just a little bit of algebra. Fine. So you have got your derivative of both left and right hand side. So I'll just combine these two terms and write it. Fine. So it will be this thing. Okay. Right? This one. Is this equation correct? Because what
Yes,
I've done is
sir.
I have just taken the derivative and just kept it over here. Fine. So over here, it is asking you what is the derivative when your value of x is 0. Okay, so it is already given to you that your value of x is equal to 0. So can I just substitute x over here as 0?
Yes, sir.
I can do it. Okay. So just for the sake of writing, I can just write dy by dx as y dash. So you'll get y dash plus. Can you tell me if I substitute x as 0, what will be the value of this term?
0, sir.
Yeah, because sin x, you have sin x, right? Sin of 0 is 0.
Yes, sir.
Great. E raised to xy, what will it be?
1, sir.
E,
Sir.
yeah, 1. E raised to 0, 1, right? Plus. What about this?
0, sir.
Yeah, whole thing, because there we have an
Yes,
x
sir.
over here, right?
Yes, sir.
So this, yeah, so it will make everything 0. So you've got your y dash value as,
4.
4.
4.
right? It looked tough, but it was not. Like all you needed to do was just apply chain rule at multiple times. Fine. Okay, great. So let us just try one logical type of question. So you have got an infinite square root of y is equal to infinite square root of under root sin x plus under root sin x plus under root sin x plus infinite times. So basically non-countable, uncountable times. And you need to find the dy by dx of this. Fine. How would we do it? You have like the square root is infinitely many times. So obviously, if you try differentiating it with respect to chain rule, like if you try differentiating it with chain rule, what will happen? You will need a chain that's infinitely long, right? So you just keep on inserting functions inside each other infinite times. So that's not possible. How else can we approach this? Have you done questions related to infinite things in physics or mathematics anytime in which you had infinitely many such things?
So I think we can write that infinite series as y.
Yeah, great. Correct. So what we can do is there is a very simple trick for such things. You'll meet with such questions in the physics section also when you deal with current, electricity, and other stuff. So what you can do is you can square both sides. Fine. So don't use chain rule over here. What you can do is you can square both sides. So basically what we are trying to do is we are trying to create an implicit function. The function is already given to me. From this function, I'll create an implicit function and use that. Fine. So can you tell me squaring both sides? My left hand side will become y square. What about my right hand side? What about my right hand side?
Sin x plus
Yeah, sin x plus. So basically my outermost square root will get removed, right? I'm
Yes.
squaring it. So my so
Yes.
like if you have got square root of some z and then you square it, so it is basically z, right?
Yes, sir.
Yes, sir.
Yeah. So what will happen is my outermost square root will get removed. So you'll get sin x plus square root sin x plus square root sin x plus square root sin x and so on. How many times will this thing come?
Sir, infinity times.
Yeah, infinite times, correct. Anyone who says infinite minus one times, I guess someone
Yes,
had
sir.
told. I
Yes,
know many people had this doubt. While studying limits, also I had told you, right? Vignesh, I guess Vignesh had told this one time. So what
yes,
is
sir.
infinite minus one? What is infinite minus one?
Infinite.
So so my function remains same. Do you agree? If
Yes,
you
sir.
take
Yes.
out a bucket out of an ocean, it still remains an ocean. It won't change into a river. Do you agree?
Yes,
Yes.
Yes.
sir.
Yeah. So that is what infinite minus one is also infinite because infinity is a very, very large number. You subtract any finite number from it, it still remains infinity. Great. So can you tell me how can this thing be written as? You have got square root of sin x plus square root sin x plus, and you have got it infinite times. So do you recognize that it is y? This thing
yes,
is equal to my function y, right? Again, I
yes,
have got y. So y square is equal to sin x plus y. I have got an implicit function. I have created an implicit function. So since I have got an implicit function already, what can I do? Tell me, what should I do in order to find my dy by dx?
Derivative, sir.
with respect to
Yeah,
x.
Different.
both sides with respect to x.
Yes,
Yes, sir.
Great. Let us do this side first, right hand side first. So can you tell me sin x? What is it? Derivative of sin x.
cos
Cos
x.
x.
Great. Plus y. Derivative of y is dy by
D.
dx
Yes.
Yes.
plus. Now you need to differentiate y square with respect to x. Y square. Can you tell me which function is inside which function?
Y is inside x square.
Great. You start from outermost side, you get x square, you differentiate it, you get 2x. So what will be the first term that you write over here?
2y.
2y,
What
sir.
will it be? 2x or 2y?
2y.
2y,
Y.
sir.
Yeah, 2y. Great. After that, you move ahead, you get y. Derivative of y is dy by dx.
Yes, sir.
Right? See, currently, like you have just started with chain rule, so that is why we are creating this web chart kind of thing. Eventually, in 2 weeks or 3 weeks, you won't even need the web chart, like something like this. Like you will just get so equipped with it, familiar with it, that you won't need to use that. Okay, fine. So you've got cos x plus dy by dx is equal to 2y plus dy by dx. So you can just take your dy by dx at one side. Dy by dx into what will it be? Tell me. What will this thing become? Anyone? I can just take dy by dx this side, so it will become 2y minus 1, right? So your value of dy by dx is cos x divided by 2y minus 1. Fine. So let us just increase the level of this question by 1. It has been told to you that the value of x is 0. Now it is asking you to find dy by dx. What can you do in this case?
We should
Who will tell
substitute
me?
x in
Great. Great.
Yes, sir.
Great. You should substitute x is equal to 0.
0.
So you have got dy by dx is equal to cos x. So what is cos of 0?
1, sir.
sir.
1 by 2y minus 1.
Y
How will
minus
you
1.
find this y? How will you find this y? Y.
Greater than 0.
How will you find this y? Like in the previous question, I had told to you beforehand that y is greater than 0. How will you find the value of this y? Anyone? Just use this equation. You have been given this equation. Just use it. Right? Or so in just substitute x is equal to 0 in this function. So you have got y square is equal to sine x plus y. So if x is equal to 0, you have got y square is equal to y. Can you tell me what are the values of y possible? Values of y.
1, sir. 1.
Only one.
0
There are two
also.
values, right?
0 and 1.
0 and
Y
1.
equal to 0, Y equal to 1, sir.
Yeah,
Yes,
y is
sir.
equal to 0 and y is equal to 1. But which one do you think we will be taking in this case? Now it is a really good question. Even though it was not a part of the question, it just came to my mind. So can you tell me,
Y is
it is
equal to 1.
1,
which one should we take? One. Everyone,
1,
sure,
sir.
one. Think again.
Yes, sir.
0, sir. 0,
Think,
sir.
think. Okay, I'll tell you. I'll show you how you can think about it. So you have got y is equal to square root of sine x plus square root sine x plus sine x plus so on. This is an unsolved example of your book only. So you can give it a try. So if x is equal to 0, what is your sine x equal to?
0, sir.
Sine of 0.
0, sir.
Yeah, sine. So it is basically y, your value of y is basically square root 0 plus square root 0 plus square root 0
0.
plus 0. What is the value till infinite?
0, sir.
Just think about it on
0.
your own. What should it be? Should it be
0.
0 or 1?
0.
0.
Yes. 0.
Obviously, it will be
0,
0,
sir.
right?
Yes,
So
sir.
this way you can remove your confusion. Great. So your value of y is 0, right? Because 0 plus square root 0 and so much infinite times, obviously it will be 0. So your value of dy by dx is, what is it? 1
Minus.
by 2y minus 1. So 2 into 0
2
minus
y
1. So it is minus 1, right?
minus.
Yes, sir.
Great. Everyone
Yes, sir.
got it? Okay.
Sir, but y is
Great.
greater than 0, na, sir?
No, that was for the previous question, not this question.
Yes,
That
sir.
was given to you in the previous question, this question. In this question, it was given to you that y is greater than 0. Not in this question. Okay?
Okay, sir.
Yeah. In this question, I had mentioned nowhere that that y is greater than 0. No. Great. Let us do one last question before going. So you have got square root of 1 minus x raised to 6 plus square root of 1 minus y raised to 6 is equal to a is any constant, a into x cube minus y cube. And it is asking you what is the value of dy by dx. How would you do it? Anyone? Tell me. No one. Like it is really simple. I don't know why you are getting
Derivative.
confused. Yeah, you differentiate with respect to x, right?
Sir.
So start from the right hand side because it looks little bit easier. So you get a into x cube. You have got x cube. What will be the derivative of x cube with respect to x?
3x squared.
Yes, sir.
How much? 3x square. Great. After that, you have got y cube. Y cube. Which function is inside which function?
Y is inside x.
Inside x cube.
Is
Yeah,
inside,
great.
sir.
Y is inside x cube. You come from outermost side, you meet x cube, you differentiate it, you
3x.
get 3x square. So what will be the thing that you write over here? 3x square?
3y squared.
3y
Square.
square. Great. You write 3y square. Great. You move inside, you meet y
dy by dx by
dx.
dy by dt.
Great. So now let us start with the left hand side. So you have got dy by dx of square root 1 minus x raised to 6. So you have got square root of 1 minus x raised to 6. Which function is inside which function? Really simple. I don't know why you're getting
D
confused.
inside dx
Which
inside
Sir, inside
what?
root x, 1 minus x raised
minus
is inserted.
Yeah, great. Correct, right? So you approach from the outermost side, you get square root x. What is the derivative of square root of x?
1 by 2 into x raised to minus 2 by 3.
Are you sure? Square root of x is what basically? Square root of x is x raised to half. Right? Square root of x is x raised to half.
1 by 2 into root
So
x.
how much?
1 by 2 into root x.
1 by 2 into root x. Sure. It will be x raised to half minus 1, right?
1 by 2.
Yes, sir.
Right? So
Yes,
half minus 1 is what? It is minus half. So it
yes,
is
sir.
half into x raised to minus half, right?
Yes,
So it is
sir.
1 by 2 root x. Fine.
Yes, sir.
Sir.
It is 1 divided by 2 root x. So what will be the first term that I write over here? Tell me.
1 minus 2 root 1 minus x raised to 6.
1 by 2 square root 1 minus x raised to 6. Correct.
Yes.
Right? Because I just need to keep my inside. So 1 minus x raised to 6 The derivative of 1 minus x raised to 6 is minus 6 into x raised to 5, right? Everyone?
Yes, sir.
Okay.
Yes, sir.
So after that, you have completed the derivative of this. Now you differentiate d by dx of square root 1 minus y raised to 6. Now I want you to do this for homework. Square root of 1 minus y raised to 6. It will go in two levels because see, inside square root of x, you have inserted 1 minus y raised to 6. So again, 1 minus y raised to 6. So again, in y raised to 6, you have got inside x raised to 6, you have inserted y. So it will come into one more level. Fine. So this is for your homework. I want to do it. I want you to do it. Fine. So that's it for today. Ma'am, please stop the recording.
Sure, sir. Thank
Okay.
you, sir.
Thank you. Thank you.
Students, join the next session.